Here we go. We're on chapter 9 on the subject of energy. We want to learn some things. Let's take a look at what we're going to learn. We want to be able to define energy after this. We want to be able to define and describe work after this, and also differentiate between work and power. It's always a tricky thing to define energy. One way I've done it in the past, it seems to work, is to think about how you could get these fan blades to turn about. I'm sure you can see there's a cord coming out of the side of this thing down at the base. So we just plug it in, right? And turn on the switch. But what's behind that outlet? Wires, you might say. Well, where do the wires come from? What, in other words, is the true source that would turn these blades round and round? Perhaps it's a solar panel attached to the roof of a house. Maybe it's a coal-fired power plant where they burn coal and shoot smoke out these huge smokestacks. Or maybe it's steam that's coming out instead from a nuclear power plant. All of these are ways that certainly could generate the electricity to turn those fan blades. Basically, what we've done here is we've taken a look at different forms of energy. We know that the fan is designed to run on electrical energy. And what we saw from the different examples is that these different sorts of sources can be changed from one form into another form. I would like to suggest that this list is not complete, that there are other types of energy. And here's just one. Maybe the fan blades are attached to an axle, and that axle runs through the body of the fan to the back where there's a pulley and some rope attached to the pulley and a weight attached to the rope, and you just let the weight drop. That would be another form of energy, gravitational. So there's different forms that energy can take. But what is energy? Well, energy, I like to say, is the stuff which is required to do work. That's a pretty good definition. It's the stuff which is required to do work. If you want to do work, you need energy. Energy is the stuff you need to do work. So what's work? You have different contexts which you can think of in which you use this word, but which of these meanings is the true meaning that we'll be using in this class? Or is there another meaning? In this class, we will define work as an amount that you can calculate by taking an applied force over a distance. So if you push something for a certain distance, you'd be able to calculate the work by taking the force that you applied times the distance that you pushed it. Let's take a look at an example. Here is a strong man. My gosh, how much weight is he lifting? Definitely requires a huge amount of force, right? Gravity's pulling down and he's pushing up. How much work would be done holding these weights up above your head like this? Well, surprising to most students that are learning about this concept, the answer is 0. The answer is 0. There's no work being done. And the reason is because at this particular moment he's not moving at any distance. He has to hold it here for a certain amount of time, maybe it's 1 or 2 seconds, before dropping it. If he's just holding it in place, he's not moving at any distance. If the distance is 0, 0 times any large force will be 0. Let's try another question. Alright, and let's not get tricked this time. Which takes more work? An 80-kilogram man who jumps up on a box, or an 80-kilogram man who steps up on a box? Now let's just make sure. Yeah, he's going up on a box. So there's distance now this time. He's raising himself up. There's a force that he has to use to push himself. How many of you are going to say A? Huh? Well, actually that's wrong. B isn't the correct answer either. In fact, if we look at this, the force for both of them is the same. It's just the guy's weight that he has to lift up, right? The distance is also the same. It's just the height of the box in each case. So the work in each case will be the same. I'm sorry, I tricked you again, maybe. You may be asking, though, there's got to be something that's different that we can measure about these two situations. And you're very wise to think that. In fact, there is something. And it's called power. Work and power are two different things. A lot of people use the word power incorrectly all the time. So work done divided by time interval is equal to power. And that's what's different about these two things. Because the time was shorter in the jump, it would require more power. Alright, go ahead and make sure you take your quiz. That's it for now.